Welcome back to another video with Matchtag Tutoring, an exam question as it appears to your screen right now. The first question that you are required to do is to get the intercept. So as we've seen with functions, to get an intercept and a y-intercept, you got to make your x equals to 0 and then substitute it in the function and determine your value of y. All right. In this case, we therefore have found that y is equals to -1. Therefore, the coordinate of the intercept is 0 is to -1. You do the same with x by making y equals to 0. All right. So moving on to the second question, which is getting the vertical asymptote. We know that your x minus 1 therefore becomes your equals to 0. Help us to determine the x asymptote, and y as your p will determine your value of q, or your y asymptote, or the horizontal asymptote. All right. So moving on to question number 3, you are required to determine obviously the range. So of f, you can see that it goes from 1 to infinity and -1 to -infinity. Okay. Question 4 is a little bit tricky, but it's doable because you are required to determine the distance AB between the 2 points of symmetry. Here we go. So you know the equation of line of symmetry. There are 2, but in here line AB is actually going up. Therefore, that means you take the one with the gradient that's going up, which is positive, and we already determined your value of P and Q, which is 1, 1. Put that in the equation, you get your K is equals to 0. Therefore, Y is equals to 0. Equate that to your function f and do the math to solve the value of x, which I assume we all know. And therefore, we arrive at x is equals to 1 minus √2, or x is equals to √2 plus 1, right? Looking at these 2 points here, A and B, that's your line y. X is y and x is x. And that's how your curve is going across A and B. So we look at the value of x, 1 minus √2. We make it positive because it's a distance by multiplying it with the negative. And then we do, so that will be a distance in the x direction from A to line y. And then we need another distance from line y to B, which is the another x that we just solved. That's √2 plus 1. We do the same thing with the y direction, okay, where we are moving from point A to x is x. That's a negative of 1 minus √2 plus from a distance from line of x to B, which is √2 plus 1. So using the analysis of triangles, theorem of Pythagoras, we are able to determine the value of AB, as you can see on our far right hand side, that AB therefore becomes 4